Greetings of the day. In this course, I would like to introduce you to the power of data structures. In our increasingly interconnected world where information is powerful currency, understanding how to organize and manipulate data is paramount. Imagine your computer's memory as a vast playground and data structures as the tool that shape and optimize that space. From simple arrays to complex graph, these structures are the architects of efficiency in computing. In this course, we will explore the fundamental concepts of arrays, linked lists, trees, and graphs. So let's understand the content of each chapter. In the first chapter, we will understand the definition of data structures. What is the importance of data structures in programming? How data structures improve the efficiency of the system? We will also see the basic concepts like what is an algorithm, what is efficiency, and how memory management could be done using data structures. Finally, we will scan through the important concepts of C programming that is essential for building data structures. In chapter 2, we will understand the most basic data structure that is an array. An array is group of similar data types. We will see how to declare an array and initialize an array with values. We will also see how to traverse and access each and every element of an array. Once we are thorough with one-dimensional array, we will understand multi-dimensional array that is required to model the real-time scenarios. Finally, we will understand the various operations that could be performed on arrays like insertion, deletion, search, finding minimum and maximum, and so on. In chapter 3, we will understand about the pointers, the need for pointers in efficient programming. We will also understand the pointer arithmetic logics, the valid and invalid pointer operations. We will study about dynamic memory allocation that will help in effective memory management. There are different functions in C programming that will help us in achieving dynamic memory allocation. So we will study the syntax of different DMA functions. Finally, we will see the power of pointers with respect to arrays and structures when they are passed or returned from functions. In chapter 4, we will understand the next data structure, which is a linked list. Unlike arrays, linked lists are dynamic in nature. So there are three different types of linked lists that we will concentrate in this course. They are singly linked list, doubly linked list, and circular linked list. So we will understand the various operations that could be performed on each of these types and list the advantages, disadvantages, and applications of each one of them. In chapter 5, we will understand the next linear data structure, which are stacks and queues. So stacks follow FIFO and queues follow FILO. So we will understand the implementation of stacks and queues using C programming based on arrays and linked lists. We will write programs to push, pop, NQ, and BQ operations. We will also understand and write codes for applications on stacks and queues. The next chapter is on the tree data structure, which is a hierarchical data structure. First, we will understand the different terminologies that are associated with trees. We will next understand the different classification of trees and the most common one, the binary tree. We will understand the feature, the characteristics, advantages, and implementation of binary trees. We will understand the different traversal methods in trees. And finally, the most famous and the most flexible tree, that is binary search trees. We will understand the various operations that could be performed on BSTs, that is binary search trees. The next chapter is graphs, where we will study the various terminologies, the types and classification of graphs. Then we will understand the various representation of graphs by using adjacency matrix, adjacency list, and incidence matrix. We will write the C code for getting the adjacency matrix and adjacency list for a given graph. Next, we will see the different graph traversal methods, which are very important to implement different graphs algorithms. And finally, we will see the applications of graph in real-time scenarios. The next chapter is searching and sorting algorithm, where we are going to study the different search and sort algorithms. We will see the algorithm, the C code implementation, and the pros and cons and the scenarios where the search and sort algorithms find application. Finally, we will do the time and space complexity analysis for different search and sort methods. The last chapter is hashing. So we will understand the need for hashing in data structure, which is a mapping technique. In order to perform hashing, we require hash functions. So we will see what are the features and different types of hash functions that are available. And most common scenario in case of hashing is collision. So in order to avoid collision, there are different resolution techniques, and we will see the different resolution techniques uh, with the C code implementation. And we will list the applications of hashing in real life. So, concluding, this course will give a clear clarity about the different data structures and its implementations. We will write a C code implementation for all the data structures that are discussed. We will understand the pros and cons and applications of various data structures so that we could relate and use them in real life applications. Thank you.